Megawatts on your mind from Lighthief. We build it, we run it, we know what works, real projects, real returns. The renewable energy podcast that doesn't waste your time. Let's go. Hello, and welcome back to Megawatts on Your Mind. This is Lighthief, and today we're discussing something that confuses many people entering the solar industry. The difference between EPC contractors and O&M providers. What exactly does each do? Where do their responsibilities begin and end? And are these roles fundamentally the same across Europe, or does every country do things differently? These aren't just academic questions. Understanding the distinction between EPC and O&M matters enormously for project success. We've seen projects where the EPC contractor built a beautiful solar farm but left behind a maintenance nightmare. We've seen O&M providers take over assets they don't understand because the EPC documentation was inadequate. We've seen disputes about warranty responsibility where EPC and O&M each blame the other for performance problems. For anyone developing, financing, or operating solar farms, understanding what EPC and O&M actually involve and where potential gaps exist between them is essential. Get it right, and you have a well-built asset that's properly maintained for 25 years. Get it wrong, and you have expensive problems that erode returns and create endless finger-pointing. The acronyms themselves tell you something. EPC stands for Engineering, Procurement and Construction. It's the process of actually building the solar farm, designing it, buying equipment, and physically constructing it. O&M stands for Operations and Maintenance. It's everything that happens after commissioning, keeping the farm running, maintaining equipment, optimizing performance, managing the asset through its operational lifetime. But these clean distinctions often blur in practice. Some EPC contractors offer O&M services, creating potential conflicts of interest. Some O&M providers get involved during construction, providing technical oversight. Some projects have integrated EPC plus O and M contracts where one company does everything, and the specific responsibilities, standards and expectations vary significantly across European markets. Today, we're going to clarify exactly what EPC and O&M involve, where the boundaries lie, how the relationship works, and crucially, how this varies across European countries. Because while the fundamental technologies are the same everywhere, the business practices, legal frameworks, and industry norms differ substantially between Germany, Spain, Poland, Italy, and other markets. At Lighthief, we've worked both sides. We've done EPC projects across Europe. We primarily provide O&M services across multiple countries. We've learned that what works in one market often needs adaptation for others. The assumptions you can make in Germany don't apply in Romania. The documentation standards expected in Netherlands differ from those in Poland. This episode is for developers trying to structure projects effectively, for investors wondering what they're actually paying for engineers considering career paths in solar, and for O&M professionals wondering how their work compares across borders. Shall we begin? And perhaps acknowledge up front that nothing in the solar industry is quite as standardized as equipment manufacturers would have you believe. Let's start by thoroughly understanding what an EPC contractor actually does, because engineering, procurement and construction doesn't fully capture the scope and complexity involved. The engineering phase begins with detailed design. The EPC contractor takes the preliminary designs and site specifications from the developer and creates construction-ready engineering documents. This includes electrical single-line diagrams showing exactly how every component connects, civil engineering plans for foundations and roads, structural calculations for mounting systems, cable routing plans, substation design, grid connection specifications. The engineering must comply with local regulations and standards. German engineering standards differ from Spanish ones, Italian grid codes have requirements that don't exist in Poland. The EPC contractor must know local requirements or hire local engineering consultants who do. This is the first place where copy-paste approaches fail. You cannot simply use German engineering documents in Romania without substantial adaptation. The engineering phase also includes obtaining permits and approvals. In some markets, the developer handles most permitting before EPC engagement. In others, the EPC contractor manages construction permits, grid connection approvals, environmental compliance. The division of responsibility varies by contract and market practice. Procurement involves buying all equipment and materials, modules, inverters, mounting structures, transformers, cables, switchgear, monitoring systems, security equipment, everything needed to build the farm. Large EPC contractors leverage volume purchasing power to negotiate better prices. Smaller contractors might have less negotiating leverage, but more flexibility in supplier selection. Procurement isn't just placing orders. It includes supplier qualification, quality assurance, logistics coordination, customs clearance in post-Brexit UK, or, when importing from outside EU, warranty registration, and ensuring all equipment meets local standards and project specifications. The timing and sequencing of procurement is critical. Long lead items like transformers might need ordering months before construction starts. Modules and inverters have shorter lead times but require coordinated delivery to avoid site storage costs. Supply chain management is a specialized skill. We've seen projects delayed months because EPC contractors underestimated transformer lead times or failed to account for customs complications. Construction is the physical building process. Site preparation, clearing vegetation, grading land if needed, building access roads. Foundation installation, driven piles, screw foundations, ballasted systems, or concrete, depending on soil conditions and mounting system. Mounting structure installation. Thousands of module mounting points installed with precision alignment, module installation. Mounting tens of thousands of modules, each needing careful handling and secure fastening. DC electrical work. Stringing modules together into strings, running DC cables to combiner boxes, installing DC protection equipment. AC electrical work. Installing inverters, running AC collection cables, building substations, installing transformers and switchgear, connecting to grid. Construction requires managing labour, equipment, logistics, quality control, and safety. Large projects might have hundreds of workers on site simultaneously. Coordinating different trades, civil crews, structural installers, electricians, equipment operators, requires experienced construction management. Quality assurance throughout construction is essential. Torque checking on structural bolts, electrical testing on every string, insulation resistance testing, thermographic inspections, documentation of installation processes. The EPC contractor should catch and correct problems during construction, not leave them for O&M to discover later. Commissioning is the final EPC phase. This involves systematically testing every system, verifying performance, obtaining grid connection approval, and handing over a fully operational facility. Commissioning includes string-by-string testing to verify electrical performance, inverter commissioning to ensure proper operation, SCADA, system configuration and testing, and performance ratio verification under actual operating conditions. The handover documentation package should include as-built drawings, showing exactly what was constructed versus initial designs, equipment warranties and manuals, test certificates and commissioning reports, maintenance manuals, spare parts lists, and operations training for the client or O&M provider. The EPC contractor's responsibility typically ends at commissioning or shortly after, though warranty periods extend longer. Most EPC contracts include defects liability periods, perhaps 1 or 2 years, during which the EPC contractor must remedy any construction defects discovered during initial operation. But here's where things get interesting. EPC contract structures vary significantly. Turnkey lump sum contracts put most risk on the EPC contractor. They commit to deliver a complete, functioning solar farm for a fixed price, regardless of cost overruns. Cost-plus contracts pass more risk to the client. The EPC contractor is paid costs plus a markup. Construction management contracts have the EPC contractor managing construction on behalf of the client, but not taking principal contractor risk. The contract structure affects how the EPC contractor approaches the work, what risks they manage, and ultimately the quality and cost of the outcome. Turnkey lump sum encourages efficient construction, but can incentivize cost cutting that compromises quality. Cost plus reduces incentive for efficiency but provides transparency. The optimal structure depends on project specifics, client capabilities, and market conditions. Performance guarantees are another variable. Some EPC contracts include guaranteed performance ratios. The contractor guarantees the installed farm will achieve minimum production levels under standard conditions. This transfers technology and installation quality risk to the EPC contractor. Other contracts simply guarantee construction completion without performance commitments, leaving performance risk with the client. From our perspective at Lighthief, when we're the EPC contractor, we focus on building quality installations with thorough documentation. We know we, or someone else, will maintain these assets for 25 years. Cutting corners during construction creates problems that cost far more to remedy than they saved initially. Professional EPC work means building it right the first time, even when that costs slightly more. Now, let's thoroughly examine what O&M providers actually do, because operations and maintenance covers an enormous scope of activities over many years. Operations encompasses the day-to-day management of running the solar farm. This includes continuous monitoring of performance, responding to alarms and faults, coordinating maintenance activities, managing vendors and contractors, reporting to asset owners, and optimizing production. The monitoring aspect is substantial. O&M providers need 24/7 visibility into system performance. Modern SCADA systems provide continuous data streams from inverters, weather stations, meters, and other equipment. Someone must watch this data, interpret it, identify problems, and coordinate responses. For portfolios of many sites, this requires dedicated operations centers with trained personnel. The monitoring isn't just watching dashboards. It requires understanding normal versus abnormal performance, recognizing patterns indicating developing problems, distinguishing between technical faults and external factors like grid curtailment or weather events. Experienced operators develop intuition for what different failure modes look like in the data. Maintenance includes both preventive and corrective work. Preventive maintenance is scheduled activities intended to keep equipment operating properly. Visual inspections, electrical testing, thermographic surveys, cleaning, vegetation management, equipment servicing according to manufacturer schedules. We've discussed these extensively in previous episodes, but the key point is they must be done systematically and thoroughly throughout the asset lifetime. Corrective maintenance responds to failures and faults. An inverter stops working, a string goes offline, a combiner box develops problems. These require diagnosis, obtaining parts, dispatching technicians, executing repairs, testing, and documenting the resolution. The speed and quality of corrective maintenance directly affects production and thus revenue. The O&M provider also manages warranties. When equipment fails under warranty, someone must identify it, gather documentation, submit claims, chase manufacturers for responses, coordinate replacement or repair, and ensure defective equipment is handled according to warranty terms. Warranty management requires meticulous record keeping and persistence. Manufacturers don't automatically honour warranties. You must prove the failure qualifies and occurred within the warranty period. Asset management is the strategic layer of O&M. This includes performance analysis against expectations, budget management for operational expenses, planning major maintenance or equipment replacements, liaising with asset owners and investors, and ensuring regulatory compliance. For portfolios of multiple assets, asset management includes optimization across the portfolio, sharing resources efficiently, identifying performance outliers, implementing lessons learned from one site across others, managing relationships with equipment suppliers and service providers who work across multiple sites. Reporting is a substantial component of O&M work. Asset owners and investors require regular reports, typically monthly or quarterly, showing production availability, maintenance activities, costs, issues, and performance against targets. These reports must be accurate, comprehensive, and delivered reliably. Poor reporting creates friction with clients, even when technical performance is good. The reporting requirements vary significantly by client sophistication. Sophisticated institutional investors want detailed performance analysis, comparing actual to modelled production with explanations for deviations, availability calculations with root cause analysis of downtime, financial reports reconciling costs to budgets, and forward-looking maintenance planning. Less sophisticated clients might accept simpler production summaries. Safety management is critical for O&M. The work involves electrical hazards, working at height, confined spaces, heavy equipment, and outdoor environments. O&M providers must implement comprehensive safety programs, training, procedures, equipment, incident reporting and investigation, continuous improvement. Safety incidents harm workers, create liability, and damage reputation. Environmental compliance is another responsibility. Managing vegetation without harming protected species, proper disposal of waste materials, preventing soil erosion and water pollution, maintaining biodiversity if required by permits. These aren't always top of mind, but can create serious problems if neglected. Stakeholder management includes dealing with landowners, local communities, utilities, grid operators, regulators, and other parties. Maintaining good relationships, addressing complaints promptly, communicating proactively about maintenance activities or outages, all part of professional O&M. The commercial aspects are significant. O&M contracts specify service levels, performance metrics, payment terms. The O&M provider must deliver contractual obligations while managing costs to maintain profitability. Balancing quality service with cost control is a continuous challenge. O&M contracts vary in structure. Fixed-fee contracts pay a set amount per megawatt per year, regardless of actual costs or performance. This is simple, but transfers cost risk to the O&M provider. Variable fee contracts tie payment to actual work performed or performance achieved. This provides more flexibility, but requires detailed time tracking and cost documentation. Performance-based contracts include bonuses for exceeding performance targets or penalties for underperformance. These align O&M provider incentives with asset owner interests, but require clear, measurable metrics and fair allocation of responsibility for factors affecting performance. Full-service O&M includes all activities from monitoring to maintenance to asset management. Limited scope O&M might include only monitoring and reporting, with the asset owner managing maintenance directly or hiring separate contractors. The scope affects pricing, responsibilities, and ultimately the quality of asset management. The duration of O&M contracts varies. Short-term contracts of 1 to 3 years provide flexibility but create uncertainty and potential for service quality degradation as contract end approaches. Long-term contracts of 5 to 10 years provide stability and enable long-term planning, but require more careful contractor selection upfront. From our perspective at Lighthief, O&M is where solar farms succeed or fail operationally. We can build a perfect solar farm, but if O&M is poor, performance will degrade. Conversely, we've taken over poorly built farms and improved performance substantially through professional O&M. The ongoing quality of operations and maintenance determines actual returns over the 25-year asset lifetime. The transition from EPC to O&M is a critical handover point. The EPC, contractor, delivers documentation, training, and a commissioned facility. The O&M provider must understand what was built, how it works, what the baseline performance should be, and what maintenance requirements exist. A poor handover creates problems that persist for years: missing documentation, unclear equipment configurations, undiscovered construction defects. Now let's discuss how EPC and O&M interact, because the relationship between building and operating can be either synergistic or problematic, depending on how it's structured. In the ideal scenario, EPC and O&M are separate but collaborative. The EPC contractor builds a high-quality asset with thorough documentation. The O&M provider takes over a well-constructed facility with complete information about what was built and how to maintain it. They cooperate during the handover period to ensure smooth transition. In practice, this ideal often doesn't happen. The EPC contractor, focused on completing construction and moving to the next project, may provide minimal documentation and abbreviated training. The O&M provider, inheriting an asset they didn't build, must reverse engineer configurations and fill gaps in knowledge. This creates friction and inefficiency. The documentation problem is surprisingly common. We've taken over O&M for farms where as-built drawings were missing, incomplete, or didn't match actual construction equipment. Warranties weren't properly registered or transferred. Test certificates from construction couldn't be located. Operations manuals were generic manufacturer documents rather than site-specific instructions. This inadequate handover creates ongoing problems. When equipment fails, the O&M provider doesn't have complete information about specifications or configurations. When making modifications, they lack accurate drawings. When claiming warranties, they can't provide installation documentation. Manufacturers require what should be straightforward operations become investigations to determine what actually exists. The conflict of interest issue arises when the same company provides both EPC and O&M. On one hand, this creates continuity. The O&M team knows exactly what was built because they built it. Documentation gaps are less problematic when internal knowledge exists. The company has long-term incentive to build well because they'll maintain it. On the other hand, the EPC division and O&M division within one company may have different incentives. EPC wants to minimize construction costs to maximize profit or win competitive bids. O&M wants quality construction to minimize maintenance costs. If EPC cuts corners, perhaps using cheaper components or taking installation shortcuts, the O&M division inherits problems but has limited ability to push back internally. We've seen situations where integrated EPC O&M providers built farms with known issues, perhaps mounting structures that would require more frequent maintenance, or inverter configurations that weren't optimal but saved costs, then provided O&M, knowing they'd have to deal with consequences. This is suboptimal, but can happen when incentives aren't properly aligned. The client perspective on integrated EPC-O&M is mixed. Some clients prefer one-stop shop simplicity, single point of responsibility, one contract, one relationship. This reduces coordination burden and provides clear accountability. Other clients prefer separation. Independent O and M can objectively assess EPC quality and doesn't have incentive to hide construction defects. The warranty and defects liability interface is another potential conflict area. During the defects liability period, typically 1 to 2 years post-commissioning, the EPC contractor is responsible for remedying construction defects. But distinguishing between construction defects, equipment failures, and operational issues isn't always clear. If an inverter fails during defects liability, is that an EPC responsibility because of improper installation or equipment warranty issue, or just random failure? If production is below expectations, is that because the EPC contractor over-promised capacity, because O&M is inadequate, or because weather was worse than modelled? These ambiguities create disputes. The relationship between EPC and O&M is most functional when first contracts clearly define responsibilities and interfaces. What documentation does EPC provide? What training? What is O&M responsible for discovering versus what EPC should have disclosed? Second, handover processes are structured and thorough. Formal commissioning procedures, comprehensive documentation packages, adequate training time, acceptance testing by O&M before final EPC acceptance. Third, defects liability and warranty processes are clear. Who diagnoses problems? Who makes warranty claims? How are disputes about responsibility resolved? Fourth, incentives align. If using integrated EPC-O&M, internal processes ensure quality construction isn't compromised for EPC profit. If using separate providers, contracts create cooperation incentives rather than adversarial dynamics. Fifth, the asset owner plays active role. Sophisticated owners don't just hire EPC and O&M, then walk away. They provide oversight during construction, verify documentation completeness, ensure proper handover, and maintain technical expertise to adjudicate disputes. From our experience at Lighthief, the cleanest structure is often separate but coordinated EPC and O&M with strong owner oversight. The O&M provider should be involved during late-stage construction, reviewing designs, attending commissioning, identifying potential operational issues. The EPC contractor should engage meaningfully in handover. Rather than treating it as formality, the owner should ensure both parties fulfill their obligations. When we provide integrated EPC-O&M, we implement internal controls to prevent conflict of interest. Our O&M team has authority to reject construction work that doesn't meet quality standards. We build to the same standards regardless of whether we'll provide O&M. This requires organizational discipline but protects long-term reputation and relationships. The practical reality: EPC and O&M are interdependent. Poor EPC creates ongoing O&M problems. Poor O&M can allow well-built assets to degrade. Success requires both doing their jobs professionally and cooperating effectively during the critical handover phase. Section 4. How it varies across Europe. Same but different. 10 to 12 minutes. Right, now let's address the crucial question. How do EPC and O&M actually differ across European countries? Is it fundamentally the same, with minor variations, or do different markets have substantially different approaches? The answer is both. The core technical work is similar. Solar farms are built and maintained using fundamentally the same technologies and methods across Europe. But the regulatory frameworks, industry practices, contractual norms, labour markets, and business cultures vary enough that direct copy-paste approaches often fail. Let's examine specific countries and highlight the important differences. Germany represents the most mature, standardized market. German engineering standards are rigorous. Documentation requirements are extensive. Quality expectations are high. Labour is expensive but skilled. EPC contractors operate in a competitive environment where reputation matters enormously. German EPC contracts typically include detailed technical specifications referencing German and international standards. Permitting is handled largely by the developer pre-EPC, though the EPC contractor often manages construction permits and grid interface details. Equipment procurement emphasizes certified compliance with German standards. German O&M is professionalized and competitive. Clients expect sophisticated monitoring, detailed reporting, comprehensive preventive maintenance O&M contracts, often include performance guarantees with clearly defined metrics. The market has numerous specialized O&M providers competing on quality and efficiency. The German approach to EPC-O&M interface emphasizes thorough documentation and formal handover processes. As-built documentation is expected to be comprehensive and accurate. Commissioning procedures are detailed. Training for O&M personnel is structured. Spain's solar boom has created a different dynamic. Rapid deployment has strained engineering and construction capacity. Many international EPC contractors work in Spain, bringing diverse approaches. Quality can vary significantly. Some projects are built to German standards, others more loosely. Spanish permitting involves substantial regional variation. Each autonomous community has different procedures. EPC contractors must navigate this fragmentation. Grid connection processes have improved, but can still be complex. Spanish O&M is maturing, but less standardized than Germany. Some clients expect German-level sophistication. Others accept more basic service. Price pressure is intense, given the competitive market. This creates risk of O&M quality degradation as providers cut costs to win contracts. The Spanish labour market includes substantial temporary and contract labour, particularly in construction. This affects EPC workforce continuity and quality control. FRUs and M providers must address high seasonal labour turnover. Italy brings additional complexity through bureaucracy and regional differences. Northern and southern Italy are almost different markets with different business practices and timelines. EPC projects in Italy often experience delays due to permitting complications, grid connection issues, or administrative obstacles. Italian EPC contractors must navigate archaeological regulations. Any groundwork might uncover Roman artifacts, triggering work stoppages. Contracts need contingencies for these delays. Documentation requirements are substantial, but enforcement is sometimes inconsistent. Italian O&M faces challenges from aging installed base. Many Italian farms are from the generous Conto Energia feed-in tariff period and are now 15+ years old. These require increasingly intensive maintenance. The O&M market serves diverse owner types, from sophisticated international funds to small agricultural operators, creating wide range of expectations. Poland represents an emerging market with rapid growth. EPC capacity was initially limited, but domestic contractors have developed capabilities rapidly. Many projects use mixed teams. Polish labour, managed by Polish or international EPC contractors, with some specialised foreign expertise. Polish permitting is relatively straightforward compared to Western Europe, though grid connection can be unpredictable. Polish labour costs are lower than Western Europe, but rising. The quality of construction varies. Some projects meet international standards. Others reflect rapid development and learning curves. Polish O&M is developing. Many farms have inadequate O&M because owners initially underestimated requirements or chose lowest cost providers. This creates opportunity for professional O&M providers to improve existing asset performance. Client sophistication is increasing as the market matures. Romania and other southeastern European markets have even more variable standards. EPC projects often involve international contractors working with local subcontractors. Quality control challenges are substantial. Documentation may be incomplete or inaccurate. O&M in emerging markets often involves remediating construction issues discovered during operations. Professional O&M providers frequently find themselves essentially completing EPC work, correcting installation errors, addressing inadequate grounding, fixing structural problems, completing missing documentation. Netherlands and Belgium represent small but sophisticated markets. Dutch projects emphasize space efficiency. Rooftop and innovative installations like floating solar EPC work requires precision and adaptation to constrained sites. O&M expectations are high with sophisticated clients. Nordic countries have specific considerations. Cold climate operation requires different approaches: snow management, heating for control systems, frozen ground affecting access. EPC must design for these conditions. O and M must address winter-specific issues. UK post-Brexit has some unique aspects. Equipment import procedures differ from EU. Some certifications and standards require UK-specific compliance. The labour market changed with reduced EU worker access, affecting both EPC and O and M workforce availability. The common threads across all markets. Technology is universal. Modules, inverters, mounting systems are largely the same equipment, regardless of location. Basic EPC processes are similar. Engineering, procurement, construction follow similar sequences. Core O and M activities are comparable. Monitoring, preventive and corrective maintenance. Reporting are fundamentally similar. The key differences that prevent copy-paste approaches. Regulatory frameworks vary. Electrical codes, safety regulations, grid requirements. Permitting processes all differ by country and sometimes region within countries. Documentation standards and expectations differ. What's adequate in Poland might be insufficient in Germany. Labour markets vary. Wages, skills availability, work practices, employment regulations differ substantially. Contractual norms differ. Standard contract structures, risk allocation, performance standards vary by market maturity and legal tradition. Business culture affects working relationships. The way EPC contractors, O and M providers and clients interact varies by national business culture. Language barriers create practical complications. Technical documentation, training, ongoing communication, all affected by language requirements. The practical implication for companies working across European markets. You need local expertise and adaptation. Templates and standard approaches must be customized for each market. An EPC approach working in Spain needs modification for Poland. An O and M service model succeeding in Germany requires adaptation for Romania. At Lighthief, operating across multiple European markets, we maintain country-specific knowledge through local staff, partnerships with local contractors, and accumulated experience. We have standard templates and approaches, but customize for each market's specific requirements and expectations. This market-by-market expertise is essential for success across Europe's diverse solar landscape. So, we've explored EPC versus O and M comprehensively, what each actually does, how they relate, and how this varies across European markets. Key takeaways: EPC contractors build solar farms, engineering, procurement, and construction from detailed design through commissioning. O&M providers operate solar farms, monitoring, maintenance, asset management throughout the operational lifetime. These are distinct roles requiring different expertise, focus, and capabilities. The relationship between EPC and O&M is critical for project success. Poor construction creates ongoing O&M problems. Inadequate handover documentation hampers O&M effectiveness. Conflicts of interest can arise when the same company provides both services without appropriate controls. The optimal structure depends on project specifics, owner capabilities, and market conditions. Integrated EPC-O&M offers simplicity and accountability, but requires internal controls to prevent quality compromise. Separate providers offer independence and specialization, but require excellent coordination and clear responsibility boundaries. Across European markets, the fundamentals are similar, but important differences exist in regulations, standards, labor markets, business practices, and expectations. Copy-paste approaches don't work. Success requires market-by-market adaptation while maintaining consistent quality standards. For developers and investors, the message is clear. Both EPC and O&M matter enormously for asset performance and returns. Select EPC contractors based on quality and reliability, not just lowest price. Select O&M providers based on capabilities and track record, not just cheapest fees. Ensure proper handover between EPC and O&M. Provide owner oversight throughout construction and operations. For professionals in the industry, understanding both sides helps. EPC engineers benefit from understanding O&M requirements. Building with maintenance in mind creates better long-term outcomes. O&M technicians benefit from understanding construction. Knowing how things were built helps diagnose and resolve problems. The solar industry needs both excellent EPC contractors who build quality installations and professional O&M providers who maintain them effectively. Neither alone is sufficient. The combination, working together effectively, delivers the 25-year performance that makes solar energy investments successful. In future episodes, we'll continue exploring different aspects of renewable energy development and operations across technologies and markets. We'll keep providing practical insights from actual project experience. This is Lighthief, reminding you that acronyms are convenient, but the real work happens on construction sites and in operations centres. EPC builds it, O&M runs it, and success requires both doing their jobs professionally. Until next time, may your EPC contractors build quality solar farms with thorough documentation. Your O&M providers maintain them professionally with attention to detail, and your handover processes actually transfer the knowledge needed for long-term success. Because when EPC and O&M both excel and work together effectively, everyone benefits: developers, investors, operators, and ultimately the energy transition we're all trying to advance.